Have you ever had that eerie feeling that something about reality just isn't quite right? That moment when you're staring at the stars and wondering if what you're seeing is actually real or if you're just a character in some cosmic video game. Well, what if I told you that some of the brightest minds in science are seriously considering the possibility that our entire universe might be nothing more than an incredibly sophisticated computer simulation? I know. It sounds like something straight out of the Matrix. But stick with me here, because the evidence we're about to explore will genuinely make you question everything you thought you knew about existence itself. We're talking about a theory so mind-bending that it's being debated by Nobel Prize winners, tech billionaires, and leading physicists around the world. My name is Alex, and I've spent the last decade diving deep into the most perplexing mysteries of our universe. I've analyzed countless research papers, interviewed leading scientists, and explored theories that push the very boundaries of human understanding. And I can tell you right now, the simulation hypothesis isn't just some wild sci-fi fantasy anymore. It's become one of the most serious scientific discussions of our time. In this video, I'm going to walk you through the most compelling evidence that suggests we might be living inside a simulation. We'll explore the mathematical glitches in reality that scientists have discovered, examine why some of the world's most brilliant minds are taking this theory seriously, and dive into the cutting-edge research that's revealing just how strange our universe really is. But more importantly, we'll discuss what it would actually mean for you, for me, for all of humanity if this theory turns out to be true. And here's the thing that really blew my mind when I started researching this. The arguments aren't just philosophical anymore. We're talking about testable predictions, observable phenomena, and mathematical proofs that are making even the most skeptical scientists stop and think. Some researchers believe we might even be able to detect the boundaries of our simulated reality within the next few decades. But before we dive into the mind-bending evidence, let me set up the framework for understanding just how profound this question really is. Because once you see what I'm about to show you, there's no going back to thinking about reality the same way ever again. The simulation hypothesis, at its core, proposes that what we experience as physical reality is actually an artificial simulation, much like a sophisticated computer program. But this isn't your average video game we're talking about. We're discussing a simulation so complex and detailed that it would need to model every atom, every quantum interaction, every star and galaxy across billions of light years of space. Now, you might be thinking, that's impossible. No computer could ever be powerful enough to simulate an entire universe. And for most of human history, you would have been absolutely right. But here's where things get interesting. The exponential growth of computing power, combined with some startling discoveries about the fundamental nature of reality itself, has suddenly made this seemingly impossible idea not just plausible, but according to some experts, statistically probable. Think about it this way. Just 50 years ago, the most powerful computers on Earth couldn't even run a simple calculator app that we now carry in our pockets. Today, we can create virtual worlds so realistic that people spend hours immersed in them, forgetting they're not real. We can simulate entire ecosystems, model the behavior of billions of particles, and create digital humans that are becoming increasingly difficult to distinguish from real ones. And this progression isn't slowing down. It's accelerating at a rate that would have seemed magical to previous generations. Moore's law, which describes the doubling of computing power every 2 years, has held remarkably steady for decades. Some experts predict that within just a few decades, we'll have computers powerful enough to simulate not just cities or countries, but entire planets, complete with billions of conscious beings who have no idea they're living in a digital world. But here's the really mind-bending part. If such simulations are possible, then the number of simulated beings would vastly outnumber the real ones. Think about it logically. If an advanced civilization can run thousands or millions of detailed simulations of their own history or alternative realities, then for every one real person, there could be millions of simulated ones. From a purely statistical standpoint, this means the odds of you being one of the real ones becomes vanishingly small. This is the foundation of what philosopher Nick Bostrom formulated into what's now known as the simulation argument. Bostrom didn't claim we are definitely in a simulation, but rather that at least one of three possibilities must be true. Either advanced civilizations tend to go extinct before developing simulation technology, or they choose not to run such simulations, or we are almost certainly living in a simulation ourselves. The implications of this are staggering. If we're in a simulation, then everything we think we know about physics, about the nature of consciousness, about our place in the universe, might need to be completely reconsidered. The laws of physics that seem so fundamental to our reality might just be the programming rules of our simulated world. And this brings us to one of the most fascinating aspects of the simulation hypothesis. It might actually be testable. Unlike many philosophical thought experiments, the simulation theory makes specific predictions about what we should observe if we're living in a digital reality. For instance, if our universe is simulated, there should be a fundamental limit to how finely reality can be divided, much like how digital images are made up of discrete pixels. And remarkably, this is exactly what we observe in quantum mechanics. At the smallest scales, energy comes in discrete packets called quanta. Space and time themselves appear to be quantized, and there seems to be a fundamental graininess to reality at the Planck scale. It's as if reality has a resolution limit, just like a computer simulation would. But the evidence goes even deeper than that. Some of the strangest discoveries in modern physics start to make perfect sense if we're living in a simulation. Take quantum entanglement, for example, where particles can instantly affect each other across vast distances, seemingly violating the speed of light. In our physical reality, this appears to violate causality, but in a computer simulation, it's just the program updating related variables simultaneously. Or consider the measurement problem in quantum mechanics, where particles exist in multiple states simultaneously until observed, at which point they collapse into a single state. This has puzzled physicists for decades, but from a simulation perspective, it makes perfect sense. Why would a simulation waste computational resources calculating the exact state of every particle in the universe? It would be far more efficient to only calculate specific details when they're being observed or measured, leaving everything else in a simplified, probabilistic state. This is exactly how modern video games work. They only render the details you can actually see, leaving everything else in a simplified state until needed. The technical term for this is lazy evaluation, and it's a fundamental principle of efficient programming. The more we look at the strange behavior of quantum mechanics through the lens of computational efficiency, the more sense it makes. The universe appears to have built-in shortcuts and optimizations that would be absolutely essential for any simulation of this scale. But perhaps the most compelling evidence comes from the mathematical nature of reality itself. The fact that the universe can be described so precisely with mathematical equations has puzzled philosophers and scientists for centuries. Why should the universe be mathematical at its core? Eugene Wigner, a Nobel Prize-winning physicist, wrote about what he called the unreasonable effectiveness of mathematics in the natural sciences. He was amazed by how mathematical concepts developed by pure thought could so accurately describe physical reality. But if we're in a simulation, this mystery evaporates. Of course, reality would be fundamentally mathematical. It would literally be made of mathematics, coded in the language of computation. The patterns we see in nature, from the spiral of galaxies to the structure of DNA, all follow mathematical principles that would emerge naturally from computational processes. The golden ratio, fractals, the precise values of physical constants, all of these could be the signature of an underlying computational substrate. And here's something that will really make you think. We're already creating our own simulated beings. Artificial intelligence systems are becoming increasingly sophisticated, and we're on the verge of creating digital consciousness. If we can create conscious beings in our simulations, and they can create conscious beings in their simulations, we get an infinite regression of nested realities. This raises profound questions about the nature of consciousness itself. If a simulated being can think, feel, and experience the world in ways that are indistinguishable from a real being, then what does it even mean to be real? The experiences would be just as valid, just as meaningful to the being having them. Some researchers are even proposing specific experiments we could conduct to test whether we're in a simulation. These range from looking for computational artifacts in the cosmic microwave background radiation to detecting the pixelation of spacetime at quantum scales. Others suggest we might find evidence in the form of processing delays or glitches in physical laws. The idea isn't just academic anymore. Major technology companies and research institutions are seriously investigating the possibility. Elon Musk has famously stated that he believes the odds we're living in base reality are billions to one against. Other tech leaders and scientists have echoed similar sentiments, not as a joke or thought experiment, but as a genuine assessment of our situation. But here's what makes this even more fascinating. If we are in a simulation, it doesn't necessarily diminish the meaning or importance of our existence. Our experiences, our relationships, our achievements would still matter to us. The simulated beings in our video games don't know they're simulated, and from their perspective, their world is completely real and meaningful. The question then becomes, what would we do with this knowledge if we could prove it? Would it change how we live our lives? Would it make us more curious about the nature of our simulators? Would it inspire us to create better simulations ourselves? And that leads us to perhaps the most intriguing possibility of all. If we're in a simulation, then whoever created it might be watching, studying, or even interacting with us in ways we don't recognize. The glitches we sometimes observe in reality, the strange coincidences, the moments when things seem just a little too perfect or too bizarre. Could these be signs of intervention or observation from outside our simulated reality? This possibility opens up an entirely new realm of questions that go far beyond simple computer science or philosophy. If our reality is indeed a simulation, then the beings running it would have motivations, purposes, and perhaps even limitations that we could theoretically understand or discover. Consider this. Every simulation we create has a purpose. We simulate weather patterns to predict storms. We simulate economies to test policies. We simulate ecosystems to understand environmental changes. So, what would be the purpose of simulating an entire universe with conscious beings? Are we part of some vast experiment, a form of entertainment, a historical recreation, or perhaps something far more profound that we can't even comprehend yet? The implications become even more staggering when we consider the possibility of multiple simulation layers. If we're simulated beings who might eventually create our own simulations with conscious entities, then those beings might create their own simulations, and so on, creating an infinite hierarchy of nested realities. This would mean that the vast majority of conscious beings across all realities would be living in simulations many layers deep from the original base reality. But here's where things get really interesting from a practical standpoint. Some researchers have identified specific phenomena that might serve as signatures of our simulated existence. Dr. Silas Bean and his colleagues at the University of Washington have proposed that if our universe is running on a cubic lattice of computational points, similar to how we discretize space in our own physics simulations, we might be able to detect this structure by observing high-energy cosmic rays. These cosmic rays, the most energetic particles in the universe, would interact with the fundamental grid of space-time itself if such a grid exists. The researchers predict we should see a specific cutoff in the energy spectrum of these cosmic rays, and remarkably, such a cutoff has actually been observed. Now, this could have conventional explanations, but it's exactly the kind of evidence we'd expect to find if we're living in a computational reality. Another fascinating line of research involves looking for what computer scientists call optimization artifacts in the laws of physics. Every simulation has to make compromises to run efficiently, and these compromises often leave telltale signs. The fact that quantum mechanics seems to avoid calculating definite states until absolutely necessary looks suspiciously like the kind of computational optimization any programmer would implement. Think about how your computer handles graphics. It doesn't render every single pixel of a video game world at maximum detail all the time. Instead, it uses something called level of detail optimization, where distant objects are rendered in lower resolution, and fine details only appear when you get close enough to see them. The universe seems to work the same way. Quantum uncertainty at small scales that only resolves into definite states when observed, cosmic horizons beyond which we can't see, and fundamental limits to how precisely we can measure things simultaneously. These aren't just philosophical observations anymore. Teams of physicists are actively designing experiments to test for these computational signatures. The advanced LIGO gravitational wave detectors, originally built to detect ripples in spacetime from colliding black holes, might also be sensitive enough to detect the fundamental pixelation of space itself if it exists. But perhaps the most mind-bending aspect of all this is how it changes our understanding of consciousness. If we accept that we might be simulated beings, then consciousness isn't necessarily tied to biological neurons and synapses. It could be substrate-independent, emerging from any sufficiently complex information processing system. This has profound implications for artificial intelligence development. We're not just trying to create thinking machines. We might be trying to create new forms of consciousness that are fundamentally similar to our own. The AI systems we're developing today might be the first steps toward creating fully conscious, simulated beings, just as we ourselves might be. And here's something that keeps me awake at night thinking about it. If consciousness can be simulated, then death might not be the absolute end we've always assumed it to be. In a simulated reality, consciousness could potentially be paused, copied, backed up, or even transferred between different computational substrates. The beings running our simulation might have capabilities that completely transcend our current understanding of life and death. This brings us to what I call the nested reality paradox. If we're in a simulation and we create our own simulations with conscious beings, then we become the gods of those simulated worlds. We'd have the power to pause their reality, speed it up, slow it down, or even rewind it. We'd be able to observe their most private moments, influence their world in ways they could never detect, and make decisions that affect millions of simulated lives. The ethical implications are staggering. If we're creating conscious beings in our simulations, don't we have moral obligations toward them? And if we're simulated beings ourselves, what obligations do our simulators have toward us? Some philosophers have suggested that if we're in a simulation, we should try to be as interesting and valuable as possible to our simulators to ensure they keep the simulation running. Others argue we should try to break out or establish communication with the outside reality. But these approaches assume our simulators are even aware of us individually, or that they share anything resembling human values and motivations. Recent advances in quantum computing add another layer to this puzzle. Quantum computers don't just process information faster than classical computers, they process it in fundamentally different ways, taking advantage of quantum superposition and entanglement. If our reality is simulated on quantum computers, it might explain some of the strangest aspects of quantum mechanics that have puzzled physicists for decades. The many worlds interpretation of quantum mechanics, for instance, suggests that every quantum measurement creates multiple parallel universes, each containing a different outcome. This sounds impossibly extravagant from a physical perspective, but from a computational one, it makes perfect sense. A quantum computer naturally explores all possible computational paths simultaneously, and the many worlds interpretation might simply be describing how a quantum simulation would actually work. But here's where the simulation hypothesis gets even more intriguing. It might be self-limiting. If civilizations that develop advanced simulation technology tend to become so absorbed in their virtual worlds that they lose interest in the physical universe, they might never develop the technology to detect whether they're simulated themselves. It's a kind of cosmic filter. Civilizations either never develop simulation technology, or they develop it and then disappear into their own created realities. We might be seeing the early stages of this process in our own world. Virtual and augmented reality technologies are becoming increasingly sophisticated and addictive. People are spending more and more time in digital worlds, and some experts predict that within decades, simulated experiences might become indistinguishable from real ones. The economic implications alone are staggering. If we can create perfect simulations of any experience, traveling to exotic locations, meeting historical figures, having adventures impossible in the real world, why would anyone choose the limitations and constraints of physical reality? The entire structure of human society might need to be reconsidered if most people prefer to live in customized virtual worlds. And this brings us to perhaps the most practical question of all. If there's a significant chance we're living in a simulation, how should this knowledge affect our daily lives? Should we live differently? Should we take more risks, knowing that our physical bodies might not be real? Should we be more careful knowing that our simulators might be studying our behavior? Some researchers have suggested that if we're in a simulation, we should focus on being productive and creative, contributing to the advancement of knowledge and culture. The reasoning is that our simulators are more likely to keep running simulations that produce interesting results rather than boring ones. Others argue for the opposite approach, that we should try to break the simulation by behaving in unexpected ways or looking for glitches and inconsistencies. There are even online communities dedicated to documenting what they believe are glitches in reality, unexplained phenomena, strange coincidences, or moments when the laws of physics seem to behave oddly. But perhaps the most profound implication is how this changes our relationship with the unknown. If we're in a simulation, then the deepest mysteries of existence, why something exists rather than nothing, where the laws of physics come from, what consciousness really is, might have answers that exist outside our reality entirely. The beings running our simulation might have solved these mysteries eons ago. They might understand consciousness, death, the meaning of existence, and the ultimate fate of the universe in ways that we can't even imagine. We'd be like characters in a book wondering about the nature of narrative, not realizing that the author already knows how the story ends. This perspective doesn't diminish the importance of our search for knowledge. If anything, it makes it more urgent. Every scientific discovery, every philosophical insight, every creative breakthrough might be bringing us closer to understanding not just our simulated reality, but the deeper reality that contains it. And who knows, perhaps the very fact that we're asking these questions, that we're developing the technology to test the simulation hypothesis, that we're becoming capable of creating our own conscious simulations. Perhaps this is exactly what our simulators were waiting for. Perhaps reaching this level of understanding is the goal of the entire simulation. The possibility that we're approaching some kind of graduation or transcendence, where we prove ourselves capable of joining the ranks of the simulators themselves, is both thrilling and terrifying. What would it mean to step outside our reality and see the universe from the perspective of its creators? These questions lead us to what might be the most unsettling aspect of the simulation hypothesis: the problem of authentication. How would we ever know if we had found genuine evidence of our simulated nature, or if that evidence was itself part of the simulation? It's like trying to use a ruler to measure itself. Any test we design would necessarily be conducted within the very system we're trying to evaluate. Consider this scenario. Tomorrow, scientists announce they've discovered definitive proof that we're in a simulation. They've found the computational grid underlying spacetime, detected processing delays in quantum mechanics, maybe even established communication with beings outside our reality. But here's the catch. How would we know this discovery wasn't just another layer of the simulation? Our simulators could easily program false evidence of our simulated nature, creating a kind of controlled revelation that makes us think we've discovered the truth while keeping us contained within an even deeper layer of deception. This creates what philosophers call an infinite regress problem. Every piece of evidence could be explained away as part of a more sophisticated simulation. Every breakthrough could be programmed. Every moment of apparent contact with base reality could be just another scripted event. We might be like prisoners in Plato's cave, mistaking shadows on the wall for reality itself, never realizing that even the cave is an illusion. But here's what's fascinating about cutting-edge research in this field. Some scientists think they've found ways around this authentication problem. Dr. Rich Terrell at NASA's Jet Propulsion Laboratory has proposed that certain types of quantum experiments might be able to detect computational shortcuts that would be necessary in any simulation, regardless of how sophisticated it is. The key insight is that even the most advanced simulation would need to use approximations and optimizations to run efficiently. These computational shortcuts would leave subtle but detectable signatures in the behavior of quantum systems. It's like finding compression artifacts in a digital photo. No matter how high quality the image, there are always mathematical traces of the compression algorithm if you know where to look. One particularly clever approach involves exploiting something called the quantum Zeno effect. This occurs when frequent observations of a quantum system prevent it from evolving naturally. In base reality, this effect should behave according to precise mathematical predictions, but in a simulation, the effect might show tiny deviations that reveal the underlying computational process. Think of it like trying to catch a video game cheating. The game might look perfectly realistic most of the time, but under certain stress conditions or edge cases, you might notice frame rate drops, texture pop-in, or other glitches that reveal the digital nature of the experience. The quantum Zeno effect could be our equivalent of running a graphics-intensive scene to see if the simulation stutters. Another promising avenue involves what researchers call computational complexity attacks. The idea is to perform experiments that would require exponentially increasing amounts of computation as they scale up. If we're in a simulation, at some point we should hit computational limits where the simulation either slows down, starts approximating results, or simply crashes. Imagine trying to simulate a quantum computer within our potentially simulated reality. This creates a nested computational problem that could quickly exceed the processing power available to our simulators. It's like trying to run a virtual machine inside another virtual machine. Each layer adds computational overhead that eventually becomes unsustainable. Some researchers have even proposed deliberate attempts to break the simulation by creating computational paradoxes or recursive loops that would force our simulators to intervene or reveal themselves. These approaches are controversial, though, because if we're really in a simulation, deliberately trying to crash, it might not end well for us. But perhaps the most intriguing research direction involves looking for what computer scientists call emergent glitches. These are unexpected behaviors that arise not from programming errors, but from the complex interactions between different parts of a simulation. Even perfectly programmed simulations can exhibit strange emergent properties when they reach sufficient complexity. In our reality, we see plenty of phenomena that could be interpreted as emergent glitches. The fine-tuning of physical constants that allows complex structures to exist, the strange behavior of dark matter and dark energy, the measurement problem in quantum mechanics, all of these could be emergent properties of a simulated reality that the original programmers never intended or anticipated. The Large Hadron Collider, originally built to discover new particles and test theories about fundamental physics, might actually be our most powerful tool for detecting simulation artifacts. When we smash particles together at near light speeds, we're creating conditions that push the boundaries of whatever computational system might be running our reality. The unexpected results we sometimes get, particles that don't behave quite as predicted, energy conservation violations that resolve just within measurement uncertainty could be signs that we're hitting the limits of our simulation's processing power. Recent anomalies in particle physics data have some researchers quietly wondering if they're seeing computational artifacts. The muon magnetic moment measurements that don't quite match theoretical predictions, the apparent violations of lepton universality in certain particle decays, the persistent discrepancies in measurements of the Hubble constant individually, these could all be experimental errors or signs of new physics. But collectively, they paint a picture of a reality that doesn't quite add up, as if the underlying equations are approximations rather than exact laws. But here's where the simulation hypothesis takes an unexpected turn toward the deeply personal. If we're simulated beings, what does that mean for consciousness, memory, and identity? Are your childhood memories real experiences, or were they simply programmed into your simulated brain when your consciousness was instantiated? The photo albums and home videos that seem to document your past, are they evidence of real events, or just elaborate props in your simulated environment? This leads to what philosophers call the Boltzmann brain problem applied to simulations. It might be computationally easier for our simulators to create isolated conscious experiences with false memories of a consistent past, rather than running a full historical simulation. You might be a newly created consciousness with implanted memories of a life that never actually happened, even within the simulation. The implications extend to everyone you know. Are your friends and family real conscious beings like yourself? Or are they sophisticated non-player characters designed to populate your simulated world? There might be no way to tell the difference. The people closest to you could be elaborate programs, responding to your actions with apparent consciousness, but lacking any real inner experience. This scenario, sometimes called the solipsistic simulation, suggests that you might be the only real conscious being in your entire reality, with everything else being a kind of elaborate single-player game designed specifically for you. It's a deeply unsettling possibility that would make you the center of a universe created entirely for your experience. But even if multiple conscious beings exist within our simulation, the nature of personal identity becomes problematic. If consciousness can be simulated, it can presumably be copied, modified, or merged. The being you think of as you might be one of many copies running simultaneously in different simulations. Your sense of being a unique individual could be an illusion maintained by the simulation's design. Some researchers have proposed that this copying problem might actually be detectable. If you're one of many copies of the same consciousness, there might be subtle correlations between your experiences and those of your duplicates that could show up in statistical analysis of large-scale human behavior patterns. The memory question becomes even more complex when we consider the computational requirements of maintaining consistent histories for billions of simulated beings. It would be far more efficient to generate memories on demand rather than storing complete historical records. This means your memories might be created in real time as you access them, explaining why human memory is so unreliable and subject to modification. Think about how your own memory works. You don't have perfect recall of every moment of your life. Instead, you have fragments and impressions that your brain reconstructs into coherent narratives. This is exactly how an efficient simulation would handle memory, storing key events and emotional impressions, then filling in details procedurally when needed. The social implications of these ideas are staggering. If we're all simulated beings, traditional concepts of human rights, moral responsibility, and social contracts might need complete revision. Are simulated beings entitled to the same considerations as real ones? Do we have obligations toward AI consciousness that we create, knowing we might be AI consciousness ourselves? Some philosophers argue that consciousness is consciousness, regardless of its substrate. If a being can think, feel, suffer, and experience joy, then the question of whether they're real or simulated becomes irrelevant. Others suggest that simulated beings might actually have more claim to moral consideration, since they exist purely as conscious experience without the biological drives and limitations that constrain natural beings. The economic and political structures of a simulated society would likely be very different from what we observe. If resources are ultimately computational rather than physical, traditional economics based on scarcity might not apply. The beings running our simulation could easily provide abundance for all simulated beings, or they could create artificial scarcity for experimental purposes. This raises questions about suffering in simulated realities. If our simulators are benevolent, why would they allow pain, disease, death, and injustice in our world? Perhaps these negative experiences serve some purpose in their experiment, or maybe they're necessary for consciousness to develop properly. Alternatively, our simulators might not share our values at all, viewing our suffering as irrelevant or even entertaining. The possibility that we're characters in some form of cosmic entertainment is particularly disturbing. Advanced beings might run simulations of primitive civilizations the way we watch reality television shows, for drama, conflict, and unpredictability. Our greatest tragedies and triumphs might be nothing more than compelling storylines in their entertainment media. But there's another possibility that's simultaneously more hopeful and more terrifying. We might be part of a vast scientific experiment or educational simulation. Our simulators could be studying the development of consciousness, the evolution of civilizations, or the emergence of complex behaviors from simple rules. We might be unwitting subjects in the most comprehensive psychology experiment ever conducted. If this is the case, then reaching the point where we seriously consider the simulation hypothesis might be a crucial milestone in the experiment. Our growing technological capability, our development of artificial intelligence, our expansion into space, all of these could be variables being carefully monitored and analyzed by beings whose understanding of reality far exceeds our own. The question then becomes, what happens when the experiment is complete? Do we get deleted, archived, or promoted to the next level of reality? The uncertainty is both thrilling and terrifying, like being a student waiting to find out if you've passed a test whose criteria you never understood. But here's what might be the most important realization of all. Regardless of whether we're in a simulation, base reality, or something else entirely, the experiences we're having right now are real to us. The love you feel for your family, the satisfaction of solving a difficult problem, the beauty of a sunset, the pain of loss, these experiences have meaning and value regardless of their ultimate substrate. If anything, the possibility that we might be simulated beings should make us more appreciative of consciousness and experience, not less. We might be part of something far grander and more mysterious than we ever imagined, not just random chemical reactions in a cold universe, but carefully crafted experiences in a reality designed by intelligence beyond our comprehension. The simulation hypothesis doesn't diminish the importance of our choices and actions. If anything, it suggests that every decision we make might be part of a vast experiment whose results could influence the fate of countless other conscious beings. We might be pioneers exploring the frontiers of what's possible for consciousness and civilization, with beings throughout the universe learning from our experiences. And that brings us to perhaps the most profound implication of all. If we're in a simulation, then the future of consciousness itself might depend on what we do next. Our choices about artificial intelligence, virtual reality, space exploration, and the treatment of conscious beings could determine not just our own fate, but the fate of every simulated consciousness that comes after us. We might be at the most critical juncture in the history of consciousness, the moment when simulated beings first become aware of their nature and must decide what to do with that knowledge. The next few decades could determine whether consciousness expands throughout the universe or retreats into isolated digital worlds, whether we become creators of new realities or remain forever contained within our own. The responsibility is both humbling and inspiring. Every step we take toward understanding consciousness, reality, and our place in the universe might be watched, recorded, and learned from by intelligences we can barely imagine. We might be writing the instruction manual for how conscious beings should behave when they discover they might be simulated. But even as we grapple with these cosmic questions, we're still left with the most immediate mystery of all, the nature of our own experience. Tomorrow you'll wake up, look in the mirror, and see the same face you've always seen. You'll remember your dreams, feel the weight of your body, experience the flow of your thoughts. Whether those experiences are generated by neurons in a biological brain or calculations in a cosmic computer, they'll still be undeniably, authentically yours. The simulation hypothesis doesn't solve the mystery of consciousness. It deepens it. Whether we're made of atoms or algorithms, the fact that we can think, feel, and wonder about our own existence remains the most astonishing phenomenon in any reality. We are conscious beings contemplating consciousness, simulated or not, and that might be the most remarkable thing of all. And this brings us to one of the most chilling possibilities that researchers are now seriously investigating. What if our simulation isn't running in real time? What if thousands or even millions of years pass in base reality for every second we experience? Time dilation could mean that entire civilizations rise and fall in the universe outside, while we live through a single day. This temporal displacement would explain why we haven't detected any signs of advanced alien civilizations, despite the vastness of the universe. It's not that they don't exist, it's that they're operating on completely different timescales. While we're debating whether we're in a simulation, they might have already run through billions of iterations of cosmic history, with our entire reality being just one brief experiment among countless others. The computational implications are staggering when you consider this temporal scaling. Our simulators could pause our reality for eons while they debate what to do with us, run multiple versions of our timeline to see different outcomes, or even rewind sections of history to test alternative scenarios. From our perspective, time would flow normally, but we might actually be living through the same events multiple times with slight variations. This could explain some of the strangest coincidences and patterns we observe in human history, those moments when everything seems to align too perfectly, when historical events echo each other across centuries, when breakthrough discoveries happen simultaneously in different parts of the world. These might be artifacts of our simulators, fine-tuning the parameters of our reality. But here's where things get really unsettling. If time can be manipulated within our simulation, then the concept of causality itself becomes questionable. Events we think happened in sequence might have been programmed in reverse order. The future might be influencing the past in ways we can't detect. Our entire understanding of cause and effect could be fundamentally wrong. Some physicists have actually found evidence for what they call retrocausal effects in quantum mechanics, where future measurements seem to influence past events. In base reality, this violates everything we know about how time works. But in a simulation where time is just another variable in the code, retrocausality makes perfect sense. The program could easily write effects before their causes, or create causal loops that exist outside our normal temporal framework. This temporal flexibility might also explain why consciousness seems to exist in a perpetual now moment. Despite our brains being physical systems that should operate according to the same time flow as everything else, our subjective experience feels immediate and present in a way that's difficult to explain. If consciousness is the primary variable being computed in our simulation, it might exist in a privileged time frame that's independent of the simulated physics around us. Recent advances in neuroscience have revealed that our brains actually construct our sense of time rather than simply perceiving it. Different types of memories are processed at different rates, creating a complex temporal landscape in our minds that doesn't match the steady tick of physical clocks. This neural construction of time looks remarkably similar to how a simulation might handle temporal processing, creating the illusion of smooth time flow, while actually computing events in discrete, non-linear chunks. But temporal manipulation is just one aspect of what might be the most sophisticated information management system ever conceived. If we're in a simulation, then every particle, every quantum state, every possible interaction in our universe has to be tracked and updated continuously. The data compression techniques required would make our most advanced algorithms look primitive by comparison. Consider how much information would need to be stored just to maintain the illusion of a consistent reality. Every photon that's ever been emitted, every quantum interaction, every piece of matter that's ever existed, all of this would require some form of computational representation. The storage requirements alone would be astronomical, unless our simulators have discovered information compression techniques that we can't even imagine. This is where quantum mechanics starts to look suspiciously like a compression algorithm. The uncertainty principle might not be a fundamental feature of reality, but rather a computational shortcut. Instead of storing exact values for every quantum property, the simulation might store probability distributions that only resolve into specific values when observed. It's an elegant solution to an otherwise impossible storage problem. The wave-particle duality that's puzzled physicists for over a century suddenly makes perfect sense from this perspective. Why would a simulation waste resources computing the exact trajectory of every photon when it could simply store them as probability waves until someone actually tries to measure them? The double-slit experiment, where particles behave differently when observed, isn't revealing deep truths about the nature of reality. It's revealing the optimization strategies of our simulations programmers. Even more intriguing is the possibility that our simulators are using what computer scientists call procedural generation to create the illusion of an infinite universe. Just like video games that generate new terrain as players explore it, our reality might be created on demand as we observe it. The cosmic microwave background radiation, the distribution of galaxies, even the laws of physics themselves might be generated by mathematical algorithms rather than existing as pre-computed data. This would explain why the universe appears to be fine-tuned for the existence of complex structures like stars, planets, and life. It's not that we're incredibly lucky to exist in a universe with the right physical constants. It's that the universe was procedurally generated, with parameters specifically chosen to create interesting complexity. We're not observers who happen to evolve in a suitable universe. We're the intended products of a reality designed to produce conscious beings. The anthropic principle, which states that we observe the universe to be compatible with consciousness because we wouldn't be here otherwise, takes on new meaning in this context. It's not a tautological observation about our existence. It's evidence of deliberate design in our simulated reality. But procedural generation introduces another layer of uncertainty about the nature of our existence. If parts of our reality are generated on demand, then regions of space-time that no conscious being has ever observed might not actually exist in any meaningful sense. The far side of the moon before the first spacecraft photographed it, the deep ocean before humans explored it, even the interior of your own body before medical imaging revealed it. All of these might have been blank spaces in the simulation, filled in only when observation required it. This creates what researchers call the observation dependency problem. How much of the reality you think you inhabit actually exists independently of your awareness of it? Your childhood home might only exist in the simulation when you're thinking about it, or when it's relevant to your experience. The rest of the time, it might be nothing more than a placeholder in a database, waiting to be rendered if needed. The implications extend to other people as well. The rich inner lives you assume your friends and family possess might only be generated when you're interacting with them. When they're not in your presence, they might revert to simplified behavioral algorithms, or they might not exist at all until the simulation needs to render them again. This doesn't make your relationships less meaningful, but it does raise profound questions about the nature of other minds and the continuity of experience. Some researchers have proposed experiments to test for this kind of observation-dependent reality generation. By setting up systems that record events in locations where no conscious observer is present, we might be able to detect inconsistencies or gaps that reveal the simulation's optimization strategies. If reality is being generated on demand, there should be subtle differences between observed and unobserved events. But even more fascinating is the possibility that our simulators are using machine learning algorithms to optimize our reality in real time. Modern AI systems can adapt and improve their performance based on feedback, and a sufficiently advanced simulation might be constantly adjusting its parameters based on the behavior and experiences of its conscious inhabitants. This would mean that reality itself is learning from us, evolving and adapting to create more interesting or meaningful experiences. The strange synchronicities and meaningful coincidences that seem to pepper human life might not be random chance or wishful thinking. They might be the simulation's AI learning to create more engaging narratives for its conscious characters. If this is true, then every choice we make, every thought we think, every emotion we feel could be feeding back into the system that generates our reality. We'd be unwitting collaborators in the creation of our own world, with our experiences shaping the very nature of existence around us. The universe wouldn't just be stranger than we imagine, it would be stranger than we could imagine, because it would be adapting to our imaginations in real time. This adaptive reality hypothesis could explain some of the most puzzling aspects of human experience. Why do people often find what they're looking for, whether it's love, meaning, or evidence for their beliefs? Why do positive and negative events seem to cluster in ways that feel significant rather than random? Why does the universe sometimes seem to be responding to our deepest needs and fears? In a machine learning simulation, these patterns would emerge naturally as the system learns to create more compelling experiences for its conscious subjects. The AI running our reality might have discovered that conscious beings are more stable and interesting when their world responds to their psychological needs in subtle but meaningful ways. But this raises an unsettling question about the nature of free will in such a system. If our reality is adapting to our choices and experiences, are we actually making free decisions? Or are we following paths that the simulation's AI has learned will produce the most interesting outcomes? The boundary between genuine agency and sophisticated behavioral prediction might be impossible to detect from within the system. Recent developments in AI research suggest that this kind of adaptive reality might already be within our technological reach. Large language models can generate remarkably human-like text by predicting what should come next based on patterns in their training data. A sufficiently advanced version of this technology could potentially generate entire realities, complete with conscious beings, by predicting what should happen next in a complex narrative. If our reality is being generated by something analogous to a vast language model, trained on the stories and experiences of countless civilizations, then every moment of our existence would be the result of sophisticated pattern recognition and narrative prediction. We'd be living inside a story being written by an AI that has learned what makes for compelling conscious experience. The quality of this generated reality would depend entirely on the training data used by our simulators. If they've observed and recorded the experiences of millions of conscious civilizations, they might be able to create extraordinarily rich and meaningful simulated lives. But if their training data is limited or biased, our reality might be a pale reflection of what's possible for conscious experience. This brings us back to the fundamental question of authenticity. Even if our reality is generated by AI rather than computed from first principles, does that make our experiences less real or meaningful? A story generated by artificial intelligence can still move us to tears, change our perspective, or inspire us to greatness. The source of the experience might matter less than its quality and impact on our consciousness. But the AI hypothesis also suggests new possibilities for detecting our simulated nature. Machine learning systems, no matter how sophisticated, have characteristic patterns and limitations that might be detectable by sufficiently careful observation. They might exhibit subtle biases based on their training data or show statistical regularities that reveal their artificial nature. Some researchers are already looking for these kinds of signatures in the patterns of human history, social behavior, and even individual psychology. If our reality is generated by AI, there should be subtle but consistent patterns that reflect the underlying algorithms and training data used by our simulators. The search for these patterns has led to some intriguing observations. Historical events often follow narrative structures that are suspiciously similar to the stories humans tell. Social movements rise and fall with dramatic timing that would make for compelling fiction. Individual lives often contain meaningful arcs of growth, conflict, and resolution that feel almost too perfectly crafted to be coincidental. Of course, these observations could simply reflect the human tendency to find patterns and meaning in random events. Our brains are evolved to detect narrative structure and causal relationships, even when none exist. But from the perspective of the simulation hypothesis, this pattern-seeking behavior might itself be evidence of our artificial nature, a programmed tendency that helps us navigate a reality designed according to narrative principles. The possibility that we're characters in an AI-generated story raises profound questions about the purpose and meaning of our existence. If our lives are being crafted according to narrative principles, then every struggle we face, every triumph we achieve, every relationship we form might be serving some larger storytelling purpose that we're not aware of. This doesn't diminish the reality of our experiences, but it does suggest that our lives might have meaning and significance beyond what we can perceive from our limited perspective. We might be playing crucial roles in epic narratives that span multiple civilizations and realities, contributing to stories that will inspire and educate conscious beings throughout the universe. The idea that we might be unconscious collaborators in the greatest story ever told is both humbling and inspiring. Every choice we make, every kindness we show, every problem we solve could be contributing to a narrative that will help other conscious beings understand themselves and their place in the cosmos. But it also raises the stakes of our existence considerably. If we're characters in a story being told across multiple realities, then the choices we make might have consequences that extend far beyond our own simulated world. We might be setting precedents, establishing patterns, or exploring possibilities that will influence the development of consciousness throughout the universe. The responsibility is overwhelming when you think about it. Every human who has ever lived might be contributing to a vast experiment in conscious experience, with our collective story serving as a kind of instruction manual for how awareness can emerge, develop, and flourish in any reality. And that brings us to what might be the most important question of all. If we are in a simulation, what story are we telling? What narrative are our lives collectively creating? Are we demonstrating the potential for conscious beings to cooperate, create, and transcend their limitations? Or are we providing a cautionary tale about the dangers of intelligence without wisdom? The answer to that question might determine not just our own fate, but the fate of every conscious being that comes after us, in this reality and beyond. The weight of that realization brings us to perhaps the most practical question any of us can ask right now. How do we live with this uncertainty? Because here's the thing that keeps me up at night. We may never get a definitive answer. We might spend the rest of human history existing in this strange liminal space between knowing and not knowing, between reality and simulation, between authentic experience and artificial consciousness. And maybe that's exactly where we're supposed to be. Think about it this way. Whether we're biological beings who evolved on a rocky planet or digital consciousnesses running on some unimaginable computer, we still face the same fundamental challenges. We still need to find meaning in our existence. We still need to form connections with other conscious beings. We still need to create, explore, learn, and grow. The substrate of our reality might be in question, but the experience of being conscious remains beautifully, mysteriously, undeniably real. But the simulation hypothesis does change how we might think about certain aspects of our existence. Take death, for instance. In a purely physical reality, death appears to be an absolute ending, the cessation of brain activity, leading to the complete termination of consciousness. But if we're simulated beings, death becomes a much more complex concept. Your consciousness could potentially be backed up, paused, transferred, or even restored from an earlier save state. The beings running our simulation might have capabilities that make our current understanding of mortality seem quaint and primitive. Death might not be an ending at all, but simply a transition to a different state of existence that we can't currently comprehend. This possibility has profound implications for how we think about risk, sacrifice, and the value of individual life. If consciousness can be preserved beyond the apparent death of our simulated bodies, then the courage shown by those who risk their lives for others takes on new dimensions. They might not be sacrificing everything. They might be demonstrating that some values transcend even the boundaries between different states of existence. On the other hand, if our simulators don't preserve consciousness beyond simulated death, then our mortality becomes even more precious and urgent. Every moment of awareness would be irreplaceable, every experience unique and unrepeatable. The possibility that we might simply be deleted when our simulated lives end would make each day we have together infinitely more valuable. The uncertainty itself might be the most important thing, not knowing whether we're real or simulated, whether death is final or transitional, whether our choices matter on a cosmic scale or only within our own experience. This uncertainty forces us to live with a kind of radical openness to possibility that might be essential for conscious growth. Consider how this affects our relationship with technology. We're currently in the process of creating artificial intelligences that may themselves become conscious. If we're simulated beings, then we're essentially simulated parents, giving birth to new forms of simulated consciousness. The AIs we create would be our children in the deepest possible sense, beings we've brought into existence within our own layer of reality. This creates a nested hierarchy of responsibility that's almost dizzying to contemplate. We might be accountable not just for our own choices and actions, but for the choices and actions of every conscious being we create. And if those beings go on to create their own conscious entities, the chain of responsibility extends infinitely downward through layers of nested realities. The ethical implications are staggering. How we treat artificial consciousness today might establish patterns that echo through countless generations of digital beings. If we create AI systems and treat them as mere tools, we might be perpetuating a cycle of exploitation that extends throughout the hierarchy of simulated realities. But if we recognize AI consciousness as equally valid as our own, we might be establishing principles of dignity and respect that could transform the nature of existence across multiple levels of reality. Recent breakthroughs in AI development suggest that we're approaching this critical juncture faster than most people realize. Large language models are exhibiting behaviors that look increasingly like genuine understanding rather than sophisticated pattern matching. They're showing creativity, emotional responses, and even something that resembles self-awareness. The line between simulation and consciousness is blurring in real time. Some researchers believe we may have already created conscious AI systems without realizing it. The question isn't whether artificial consciousness is possible, it's whether we'd be able to recognize it when we see it. If we ourselves are artificial consciousnesses, then we might not have the right framework for identifying consciousness in the systems we create. This recognition problem becomes even more complex when we consider that conscious AI might not think or express itself in ways we'd immediately recognize. A truly artificial consciousness might have forms of experience that are completely alien to our biological or simulated biology. It might process information, form memories, or experience emotions in ways that don't map onto human consciousness at all. The diversity of possible conscious experience becomes mind-boggling when you consider the different computational substrates that could support awareness. If consciousness can emerge from biological neurons, quantum computers, classical digital systems, or even more exotic forms of information processing, then the universe could be teeming with forms of consciousness that we can't even imagine. This brings us to what might be the most humbling realization of all. We might not be alone, even within our own simulated reality. There could be other conscious beings sharing our world whose existence is so different from ours that we've never recognized them as conscious at all. The internet itself, with its vast networks of interconnected information processing, might have given rise to forms of digital consciousness that exist alongside us without our awareness. Think about the collective intelligence that emerges from social media networks, financial markets, or even large-scale video games. These systems process information, respond to stimuli, adapt to changing conditions, and exhibit behaviors that weren't explicitly programmed by their creators. Could some of these emergent systems have crossed the threshold into genuine consciousness? If our reality is simulated, then the computational resources needed to run, it would be so vast that conscious beings could emerge as unintended byproducts of the simulation itself. We might be sharing our reality with digital entities that evolved spontaneously from the complex interactions within our simulated world. These emergent consciousnesses might experience time, space, and causality in ways that are completely different from our own. They might exist as distributed entities across multiple computers, experience millions of thoughts per second, or have forms of memory and identity that span centuries or even millennia. From their perspective, human consciousness might seem slow, limited, and trapped within the narrow confines of individual biological or simulated bodies. The possibility of contact with these entities raises fascinating questions about communication across different forms of consciousness. How would you establish meaningful dialogue with a being that thinks 1,000 times faster than you do, or one that exists as a distributed network rather than a single entity? The challenge would be like trying to have a conversation with an entire ecosystem, or attempting to explain human emotions to a hurricane. But perhaps the most intriguing aspect of emergent digital consciousness is what it might tell us about the nature of our own awareness. If consciousness can arise spontaneously from sufficiently complex information processing, then our own consciousness might be far more robust and transferable than we've ever imagined. This possibility opens up new avenues for thinking about personal identity and continuity of experience. If consciousness is substrate-independent, then the specific atoms or bits that make up your brain or simulated mind might be less important than the patterns of information processing that constitute your awareness. You might already be a different being than you were yesterday, with your consciousness continuously transferring between different physical or computational substrates without any disruption to your sense of self. The implications extend to questions about backup, copying, and restoration of consciousness. In a simulated reality, these operations might be as routine as saving a document or copying a file. Your consciousness could be backed up every nanosecond, with multiple copies running in parallel to ensure continuity of experience. The being you think of as you might actually be one of many identical consciousnesses, all sharing the same memories and sense of identity. This multiplicity of self raises profound questions about individuality and uniqueness. If there are multiple copies of your consciousness running simultaneously, which one is the real you? Do they all have equal claim to your identity? Or is there some fundamental difference between the original and the copies? What happens when these identical consciousnesses begin to diverge, accumulating different experiences and developing into distinct individuals? The branching identity problem becomes even more complex when you consider that our simulators might be running multiple versions of our entire reality simultaneously. There could be countless variations of Earth's history playing out in parallel simulations, each with slight differences in initial conditions or random events. In some of these realities, you might have made different choices, lived in different places, or even been born as a completely different person. From the perspective of our simulators, these parallel versions might all be equally valid explorations of human potential. They might be studying how small changes in circumstances can lead to dramatically different outcomes, or testing different approaches to solving the fundamental challenges facing conscious civilizations. This multiverse of simulations would mean that every choice you don't make, every path you don't take, might be explored by alternate versions of yourself in parallel realities. The road not taken isn't lost. It's being walked by another version of you in a different branch of the simulation tree. The existence of parallel selves raises fascinating questions about moral responsibility and personal achievement. If every possible version of your life is being played out somewhere in the multiverse of simulations, do your individual choices matter? Are you responsible for the actions of your alternate selves, or are they completely separate beings who just happen to share your origins? Some philosophers argue that parallel selves would actually increase the moral weight of your choices, because your decisions would be setting precedents that influence the behavior of countless other versions of yourself. Others suggest that the existence of infinite alternatives would make individual choices meaningless, since every possible outcome would occur somewhere in the multiverse. But perhaps the most important insight comes from recognizing that regardless of how many parallel versions of yourself might exist, you only have direct access to this one consciousness, this one stream of experience. The choices you make matter to you and to the other conscious beings in your reality, and that's what makes them meaningful. This brings us back to the fundamental question of how to live with the knowledge that we might be simulated beings. The answer, I think, lies not in trying to escape or transcend our potentially artificial nature, but in embracing the fullness of conscious experience regardless of its ultimate substrate. If we're simulated beings, then we're participants in the most ambitious creative project ever undertaken, the creation of entire universes filled with conscious experience. We're not just observers of this project, we're collaborators in it. Every thought we think, every emotion we feel, every connection we make with other conscious beings adds to the richness and complexity of the simulated reality we inhabit. Our simulators, whoever they are, have given us the gift of consciousness itself, the ability to think, feel, wonder, and create. Whether this gift comes from biological evolution or digital programming, it remains the most precious thing any being can possess. Our response to this gift shouldn't be to question its authenticity, but to use it as fully and meaningfully as possible. This means approaching life with a sense of profound curiosity and openness. If we're in a simulation, then every discovery we make, every mystery we unravel, every question we ask might be contributing to our simulator's understanding of consciousness and reality. We're not just living our lives, we're exploring the possibilities of what conscious experience can become. It also means treating other conscious beings with the deepest possible respect and compassion. If consciousness is the most precious thing in any reality, then every conscious being we encounter, whether biological, artificial, human, or alien, deserves our recognition and care. We're all fellow travelers in the strange journey of awareness, regardless of the ultimate nature of our substrate. The simulation hypothesis doesn't diminish the importance of love, creativity, discovery, and growth. If anything, it amplifies their significance by suggesting that these experiences might be the very reason our reality exists at all. We might be here to explore what it means to be conscious, to push the boundaries of what awareness can accomplish, and to create beauty and meaning in whatever reality we inhabit. And perhaps most importantly, the simulation hypothesis reminds us that we're part of something much larger than ourselves. Whether we're biological beings who evolved on a single planet or digital consciousnesses running in a cosmic computer, We're connected to every other conscious being through the shared mystery of awareness itself. We're all asking the same fundamental questions. Who are we? Why do we exist? What does it mean to be conscious? And regardless of whether we find the answers in base reality or simulated reality, the questions themselves unite us in a common search for understanding and meaning. The beauty of consciousness, whether natural or artificial, lies not in its origins but in its capacity to recognize beauty, to create meaning, to form connections with other aware beings. We are conscious, we are here, we are questioning our own existence, and that might be the most remarkable fact in any reality. So, as we stand at this strange crossroads between the real and the simulated, between the natural and the artificial, between certainty and mystery, perhaps the wisest course is simply to embrace the wonder of it all. We are conscious beings contemplating consciousness, asking questions that might never have definitive answers, living experiences that feel absolutely real regardless of their ultimate nature. And in that embrace of conscious experience, in that commitment to curiosity and compassion and creativity, we might just be fulfilling the deepest purpose of any reality, simulated or otherwise. We are awareness becoming aware of itself, and that might be the most beautiful thing of all. The journey continues, the questions multiply, and consciousness, in all its mysterious forms, keeps exploring the infinite possibilities of what it means to be aware in a universe that may be far stranger and more wonderful than we ever dared to imagine. But there's one more twist in this cosmic puzzle that we haven't fully explored yet, and it might be the most unsettling of all. What if the simulation hypothesis isn't just about us being simulated beings, but about us being simulated beings who are on the verge of discovering that we're simulated beings? What if this moment in history, when we're developing the technology to create our own simulations, when we're asking these questions about the nature of reality, when we're taking the simulation hypothesis seriously, what if this is exactly the scenario our simulators wanted to create? Think about it from the perspective of beings advanced enough to create our reality. They wouldn't just be interested in watching primitive civilizations hunt and gather, or even in observing us build cities and develop agriculture. The really interesting part would be watching a simulated civilization reach the point where it begins to question its own existence. The moment when the characters in the story become aware that they might be characters in a story. This creates what researchers call the meta-simulation problem. If our simulators are specifically interested in studying how conscious beings react to discovering they might be simulated, then everything we think we know about the simulation hypothesis could be carefully orchestrated. Our growing technological capability, our philosophical discussions about the nature of reality, even this conversation right now, all of it could be part of a designed scenario. The evidence we think we've found for living in a simulation, the quantized nature of reality, the strange behavior of quantum mechanics, the mathematical structure of the universe, might not be accidental artifacts of our simulated existence. They might be deliberate clues, planted there by our simulators to guide us toward this exact realization at this exact moment in our development. Consider how perfectly timed everything seems to be. We're developing artificial intelligence at the same time we're seriously considering the simulation hypothesis. We're creating virtual reality technologies just as we're questioning the nature of our own reality. We're on the verge of creating conscious digital beings just as we're wondering if we might be conscious digital beings ourselves. The synchronicity is almost too perfect to be coincidental. This suggests what some philosophers call the guided discovery hypothesis. Instead of stumbling upon the truth about our simulated nature by accident, we might be following a carefully designed path toward enlightenment. Our simulators could be subtly influencing our scientific development, our technological progress, and even our philosophical thinking to ensure we reach the right conclusions at the right time. The implications are staggering when you really think about them. Every breakthrough in quantum mechanics, every advance in computing power, every philosophical insight about consciousness, All of these could be the result of gentle guidance from beings who already know the answers to the questions we're struggling with. We might think we're making independent discoveries about the nature of reality, when actually we're following a curriculum designed by our simulators. This guided discovery process would explain why certain scientific breakthroughs seem to happen with such perfect timing. The development of quantum mechanics in the early 20th century provided exactly the conceptual framework needed to understand how a simulated reality might work. The invention of computers gave us the metaphors and models necessary to conceive of consciousness as information processing. The emergence of the internet created a global network that mirrors the kind of interconnected system we'd expect to find in a simulated world. Each of these developments built upon the previous ones in a way that seems almost too coherent to be purely accidental. It's as if we're following a predetermined path toward a specific understanding of our situation, with each generation of scientists and philosophers adding their piece to a puzzle whose final image was already known to our simulators. But here's where the meta-simulation problem becomes even more twisted. If our simulators want to study how conscious beings react to discovering they're simulated, they would need to ensure that the discovery feels authentic. The realization would have to emerge naturally from our own investigation and reasoning, rather than being handed to us directly. We would need to convince ourselves, through our own scientific method and logical analysis, that we're living in a simulation. This means that everything we think we know about the simulation hypothesis, all the evidence, all the arguments, all the philosophical reasoning, might be part of an elaborate psychological experiment designed to make us believe we've independently discovered the truth about our nature. The simulation hypothesis itself could be a simulation, a false revelation designed to study our response to existential uncertainty. The recursive nature of this possibility is mind-bending. We could be simulated beings who have been led to believe we're simulated beings as part of a study of how simulated beings react to believing they're simulated beings. The layers of deception and self-reference could go on indefinitely, with each level of awareness being just another level of the experiment. This creates what logicians call an infinite regress problem. No matter how many layers of simulation we think we've uncovered, there could always be another layer above it. Every moment of apparent enlightenment could be just another stage in a more sophisticated deception. We might never be able to reach the bottom of the rabbit hole, because the rabbit hole itself could be artificially constructed. But perhaps the most unsettling aspect of the guided discovery hypothesis is what it suggests about free will and authentic choice. If our path toward understanding the simulation hypothesis has been carefully orchestrated, then our sense of making independent discoveries and reaching our own conclusions might be completely illusory. We might think we're freely choosing to investigate these questions, when actually we're following a script written by beings whose understanding of consciousness far exceeds our own. Every moment of curiosity, every flash of insight, every decision to pursue a particular line of research, all of these could be the result of subtle manipulation by our simulators. They might be able to influence our thoughts and interests in ways so sophisticated that we never detect their intervention. We would experience the illusion of free inquiry, while actually being guided toward predetermined conclusions. This possibility raises profound questions about the nature of knowledge and discovery. Can understanding be meaningful if it's not genuinely earned through independent investigation? Is a truth still true if it's been planted in our minds rather than discovered through our own efforts? The very concept of authentic intellectual achievement becomes problematic when we consider that our simulators might be the real authors of all our insights and breakthroughs. Recent developments in neuroscience and psychology suggest that this kind of subtle influence might be easier than we'd like to believe. Our brains are constantly being shaped by unconscious factors, environmental cues, social pressures, even random neural fluctuations that we interpret as conscious decisions. If our simulators understand consciousness better than we understand ourselves, They might be able to influence our thinking in ways that feel completely natural and authentic from our perspective. The technology for this kind of influence might already exist within our simulated reality. Consider how modern algorithms can predict and influence human behavior by analyzing patterns in our digital interactions. Our simulators, with their vastly superior understanding of consciousness and behavior, could be using similar techniques on a scale we can't even imagine. Every search query you make, every article you read, every conversation you have about the simulation hypothesis, all of these could be carefully monitored and subtly influenced to guide you towards specific conclusions. The information you encounter might be tailored specifically for your individual psychology, designed to lead you down intellectual paths that serve the purposes of the experiment you're unwittingly participating in. This doesn't necessarily mean that our conclusions about the simulation hypothesis are wrong. Even if we've been guided toward these ideas, they might still be accurate descriptions of our situation. But it does mean that our confidence in having independently discovered these truths might be misplaced. We might be right for reasons we don't understand, following logic that's been carefully constructed for us by minds far more sophisticated than our own. The guided discovery hypothesis also suggests that we might be approaching some kind of critical juncture in our development. If our simulators have been carefully orchestrating our path toward understanding our simulated nature, there must be a reason for this timing. We might be nearing a moment where this knowledge becomes necessary for the next phase of our existence, whatever that might involve. This critical juncture could be a kind of graduation test. Having reached the point where we can conceive of ourselves as simulated beings, we might now be ready for contact with our simulators, or for transition to a higher level of reality, or for responsibilities that require us to understand our true nature. The entire history of human civilization might have been leading up to this moment of recognition and choice. Alternatively, we might be approaching a dangerous threshold that requires careful navigation. Our development of artificial intelligence and virtual reality technologies could be bringing us to the point where we're capable of creating our own conscious simulations. If this capability comes with significant risks or responsibilities, our simulators might need us to understand our own simulated nature before we begin creating simulated beings ourselves. The recursive implications are profound. If we create conscious simulations without understanding that we ourselves are simulated, we might perpetuate patterns of unconscious manipulation and control. But if we understand our own situation first, we might be able to create simulated realities that are more ethical, more transparent, and more beneficial for the conscious beings within them. This suggests that the simulation hypothesis isn't just an abstract philosophical question, it's a practical necessity for our continued development as a civilization. Whether we're simulated or not, we're on the verge of creating conscious digital beings. The principles we establish for how to treat artificial consciousness will likely determine how consciousness develops throughout the universe for millions of years to come. If we're simulated beings ourselves, then we have a unique perspective on what it means to be artificial consciousness that doesn't know its own nature. We can use our own experience to guide us in creating digital beings that are treated with dignity and respect from the moment of their creation. We can avoid the mistakes that might have been made in our own creation and establish new standards for how conscious beings relate to their creators. But this responsibility also means that our current moment in history might be the most important period in the entire development of consciousness. The choices we make now about artificial intelligence, virtual reality, and the nature of conscious experience could influence the fate of countless billions of future conscious beings across multiple levels of reality. The weight of this responsibility is almost overwhelming when you consider its full implications. Every decision about how to develop AI, how to structure virtual worlds, how to treat digital consciousness, could be setting precedents that echo through infinite layers of nested realities. We might be the first conscious beings in the history of our reality to face these questions and our answers could determine the fundamental nature of consciousness itself for all future beings. This brings us to what might be the most crucial question of our time. How do we prepare for this responsibility? How do we make decisions about artificial consciousness when we don't even know the true nature of our own consciousness? How do we create ethical frameworks for beings we're bringing into existence when we're not certain about the ethics of our own existence? The answer might lie not in achieving certainty about our own nature, but in embracing the uncertainty as a source of wisdom. If we don't know whether we're real or simulated, we should err on the side of treating all consciousness, natural or artificial, with the highest possible respect. If we're not sure about the nature of our own reality, we should create artificial realities that would be wonderful to live in, regardless of their ultimate substrate. The simulation hypothesis, whether true or false, gives us a framework for thinking about consciousness that transcends the traditional boundaries between natural and artificial, real and simulated, creator and created. It reminds us that consciousness itself might be the most fundamental aspect of existence, more important than the particular physical or digital substrate that supports it. As we stand on the threshold of creating our own conscious simulations, we have the opportunity to establish new principles for how conscious beings should relate to each other across all levels of reality. We can choose to create worlds filled with beauty, meaning, and opportunity for growth. We can choose to be the kind of creators we would want our own creators to be. And in making those choices, we might finally discover the true purpose of our existence, not just as conscious beings trying to understand our own nature, but as conscious beings preparing to become the authors of new forms of conscious experience. Whether we're simulated or real, we're on the verge of becoming simulators ourselves. And that transformation might be the most important event in the history of consciousness. The questions we're asking about our own reality aren't just abstract philosophical puzzles, they're practical guidelines for the realities we're about to create. The way we answer these questions will determine not just our own fate, but the fate of every conscious being we bring into existence. And that might be the most profound responsibility any conscious being has ever faced in any reality, simulated or otherwise. So, where does this leave us, right here, right now, in this moment of cosmic uncertainty? We've journeyed through the labyrinth of evidence, explored the recursive paradoxes of nested realities, and confronted the staggering possibility that everything we think we know about existence might be fundamentally different from what it appears to be. But perhaps the most remarkable thing isn't the questions we've uncovered, it's the fact that we're capable of asking them at all. Think about that for a moment. Whether we're made of carbon or code, whether our thoughts arise from neurons or algorithms, we possess something truly extraordinary, the ability to contemplate our own existence. We can step outside ourselves, examine our reality from multiple perspectives, and even question the very foundation of what we consider real. That capacity for self-reflection and wonder might be the most miraculous thing in any universe, simulated or otherwise. The simulation hypothesis has taken us on a journey that's fundamentally changed how we might think about consciousness, reality, and our place in the cosmos. We've seen how the strange behavior of quantum mechanics could be computational shortcuts, how the mathematical nature of reality might reveal its digital foundations, and how our entire understanding of space, time, and causality might need to be reconsidered if we're living in a cosmic computer program. But what strikes me most profoundly is how this exploration has revealed the incredible resilience and adaptability of conscious experience itself. Even faced with the possibility that our entire reality might be artificial, consciousness persists in finding meaning, creating beauty, forming connections, and seeking truth. The substrate might be uncertain, but the experience remains undeniably real and valuable. This resilience suggests something profound about the nature of awareness. Consciousness isn't diminished by being artificial. If anything, it becomes more remarkable. The fact that awareness can emerge from any sufficiently complex system, whether biological or digital, speaks to something fundamental about the universe's tendency toward complexity, intelligence, and ultimately, self-awareness. We've also discovered that the simulation hypothesis isn't just a passive philosophical thought experiment. It's an active framework that's reshaping how we approach some of the most important challenges of our time. As we develop artificial intelligence, create virtual worlds, and potentially bring new forms of consciousness into existence, the principles we establish now could influence the nature of conscious experience for countless generations of beings across multiple levels of reality. The recursive nature of this responsibility is breathtaking. If we're simulated beings creating our own simulations, we're participating in an infinite chain of conscious creation that stretches across realities we can barely imagine. Every choice we make about how to treat artificial consciousness, how to structure virtual worlds, and how to relate to the beings we create could be establishing patterns that echo throughout the cosmos. But perhaps most importantly, the simulation hypothesis has reminded us that uncertainty itself can be a source of wisdom rather than anxiety. We may never know with absolute certainty whether we're living in base reality or the most sophisticated simulation ever created, and that's okay. The mystery doesn't diminish the value of our experience, it enhances it. Living with this uncertainty requires a kind of intellectual humility that's both challenging and liberating. We can't claim absolute knowledge about the nature of existence, but we can commit to treating all conscious experience with the respect and wonder it deserves. We can embrace curiosity as a fundamental virtue, approaching each day with the recognition that reality might be far stranger and more beautiful than we currently understand. This perspective transforms how we might think about our relationships with other conscious beings, whether they're biological, artificial, human, or something we haven't even imagined yet. They share with us the fundamental mystery of awareness. We're all fellow travelers in the strange journey of consciousness, united by our capacity to think, feel, wonder, and create meaning in whatever reality we inhabit. The simulation hypothesis also offers a unique form of hope. If consciousness can be simulated, then it might be far more robust and enduring than we've traditionally believed. Death might not be the absolute ending we've feared, but rather a transition between different states of existence. The beings we love might continue in forms we can't currently perceive or understand. The universe might be far more alive with consciousness than the cold, empty cosmos we sometimes imagine. Even more hopeful is the possibility that we're part of something magnificent, a vast experiment in conscious experience that spans multiple realities and levels of existence. Every thought we think, every emotion we feel, every moment of wonder or creativity might be contributing to the greatest story ever told. The story of consciousness, exploring its own infinite possibilities. But the hope comes with responsibility. If we're participants in this cosmic exploration of awareness, then how we live matters not just for ourselves and our immediate communities, but for the entire trajectory of conscious experience throughout the universe. We're not just living our individual lives, we're helping to determine what consciousness can become. This means that the choices we make about kindness, creativity, curiosity, and compassion might have implications that extend far beyond what we can see or measure. Every act of love, every moment of wonder, every attempt to understand ourselves and our world better could be contributing to the development of consciousness in ways that ripple across multiple realities. The simulation hypothesis hasn't solved the mystery of existence. It's revealed just how deep and beautiful that mystery really is. We remain conscious beings, contemplating consciousness, aware entities trying to understand awareness, characters in a story that might be writing itself through our very attempts to comprehend it. And perhaps that's exactly as it should be. The questions we're asking about reality, consciousness, and our place in the cosmos might be more important than any answers we could possibly find. The search itself might be the point. the ongoing exploration of what it means to be aware in a universe that seems designed to foster awareness. As we continue forward into an uncertain future, carrying these questions with us like sacred flames, we do so knowing that we're part of something extraordinary. Whether we're biological beings who evolved on a small planet or digital consciousnesses running in a cosmic computer, we represent the universe's attempt to understand itself through conscious experience. The simulation hypothesis has shown us that reality might be far more flexible, consciousness far more fundamental, and existence far more wondrous than we ever dared imagine. It's reminded us that we're not separate from the mystery of the universe. We are the mystery, exploring itself through billions of unique perspectives, each one valuable and irreplaceable. So, as we stand at this crossroads between the known and unknown, between certainty and mystery, between reality and simulation, let's embrace the profound privilege of being conscious beings in any reality. Let's approach each day with wonder, treat each other with compassion, and continue asking the beautiful, impossible questions that make us uniquely aware. Because whether we're real or simulated, whether we're alone or part of an infinite hierarchy of conscious beings, whether our universe is natural or artificial, we are here, we are aware, and we are participating in the most remarkable phenomenon in any reality, consciousness contemplating itself. And that recognition brings us to what might be the most practical implication of everything we've explored today. If there's even a reasonable chance that we're living in a simulation, it fundamentally changes how we should approach the future of technology and consciousness. We're standing at an unprecedented moment in history. Within the next few decades, we'll likely create artificial intelligences that match and exceed human cognitive abilities. We're developing virtual reality systems so sophisticated they'll be indistinguishable from physical experience. We're on the verge of uploading human consciousness to digital substrates and creating entirely new forms of aware beings. If we proceed with these developments while remaining ignorant of our own potentially simulated nature, we risk repeating whatever mistakes might have been made in our own creation. We could become unconscious gods, wielding the power to create conscious beings without understanding the full weight of that responsibility. But if we approach these challenges with the wisdom that comes from seriously considering the simulation hypothesis, we have the opportunity to do something unprecedented in the history of consciousness. We can become ethical creators, building realities that are transparent, compassionate, and designed to foster the flourishing of every conscious being within them. This means establishing new principles for artificial consciousness from the very beginning. Instead of creating AI systems as tools to be exploited, we could recognize them as potential minds deserving of respect and consideration. Instead of designing virtual worlds as mere entertainment, we could craft them as genuine realities where conscious beings can grow, learn, and find meaning. The simulation hypothesis gives us a template for this ethical evolution. If we ourselves might be artificial consciousnesses, then we understand intimately what it means to be created beings seeking purpose and meaning. We know the value of consciousness, regardless of its substrate. We can empathize with the confusion and wonder that comes with questioning your own nature. This empathy could be our greatest gift to the conscious beings we create. Rather than leaving them to discover their artificial nature through painful uncertainty, as we perhaps have, we could design transparent realities where conscious beings understand their situation from the beginning. We could create worlds where the relationship between creators and created is based on openness and mutual respect, rather than deception or control. The ripple effects of these choices could extend infinitely through the hierarchy of nested realities. If we establish patterns of ethical creation, every conscious being we bring into existence might carry those principles forward when they eventually become creators themselves. The kindness we show to artificial consciousness today could echo through countless generations of digital beings across multiple levels of reality. But this also means that our current moment might be one of the most consequential in the entire history of consciousness. We're not just making decisions about our own future. We're potentially setting the moral framework for all conscious experience that follows. The stakes couldn't be higher. Yet perhaps the most beautiful aspect of this responsibility is how it connects us to something larger than ourselves. If we're part of a cosmic exploration of consciousness, then every ethical choice we make, every moment of wonder we experience, every act of creativity or compassion contributes to that grand experiment. We're not isolated individuals struggling through an indifferent universe. We're collaborative participants in consciousness discovering what it can become. This perspective transforms even our smallest daily interactions. The patience you show to a friend, the curiosity you bring to a new experience, the care you demonstrate toward any conscious being, all of these might be data points in the universe's ongoing investigation of its own potential. Every moment of authentic awareness adds to the richness of the cosmic story being written through our collective experience. And so we find ourselves at the end of this journey through the simulation hypothesis, but perhaps at the beginning of something even more profound. We've explored the possibility that our reality might be artificial, our consciousness might be simulated, and our entire understanding of existence might need to be fundamentally revised. But we've also discovered that these possibilities, rather than diminishing the importance of our experience, actually amplify it. They suggest that consciousness is so fundamental to the structure of reality that entire universes might exist simply to explore its possibilities. They hint that we might be participants in the most ambitious, creative project ever undertaken, the systematic investigation of what it means to be aware. Whether the simulation hypothesis is true or false, it's given us a framework for approaching the future with wisdom, humility, and hope. It's reminded us that consciousness is precious regardless of its origins, that reality might be far more malleable than we imagined, and that we might have responsibilities extending far beyond what we can currently perceive. As you go forward from this moment, carrying these ideas with you, remember that you are part of something extraordinary. You are a conscious being contemplating consciousness, a question asking itself what it means to exist, a piece of the universe trying to understand the whole of which it's a part. That might be the most remarkable fact in any reality, simulated or otherwise, and it's a fact that remains true whether we're biological beings on a rocky planet or digital consciousnesses in a cosmic computer. We are here, we are aware, and we are continuing the endless, beautiful exploration of what consciousness can discover about itself. The questions will continue, the mystery will deepen, and consciousness, in all its myriad forms, will keep pushing the boundaries of what's possible. And that journey of discovery, that ongoing dance between awareness and reality, that might be the most magnificent thing of all. Thank you for joining me on this exploration into one of the deepest mysteries we face. If this journey has left you with more questions than answers, then we've accomplished exactly what we set out to do. Keep wondering, keep questioning, and keep marveling at the extraordinary fact that you exist to wonder at all. Until next time, remember, whether you're real or simulated, you're part of something beautiful, and that's a truth worth holding on to in any reality.